So right now we're going to talk about grams, moles, and atoms. Grams, moles, atoms. That's where we're going to start as we move in with the review. That essentially we have 3 or 4 different levels when it comes to dealing with things. The smallest level is our atoms. From there, we can go from atoms to molecules. And then we see a huge size increase as we go from molecules to moles. And from there, we can go moles to grams. Those are our various size differentials that we're going to have to be dealing with. The difference between atoms and molecules would be looking at a chemical formula. For example, if I looked at, say, Fe2O3. If I looked at this and I looked at, okay, as a molecule, that is one molecule of Fe2O3. It's a formula unit for a larger crystal structure of hematite or just rust, larger structure of that. If I look at an individual molecular level, it's one molecule. But on an atomic level, there's 2 iron atoms and 3 oxygen atoms. So on an atomic level, you could break it down into 2 and 3 based on the fact that our subscripts say 2 and 3. From there, we can, on an individual molecule level, we could upscale it to figure out moles. A mole, remember, is a convenient way of measuring a lot of molecules, a lot of atoms. 1 mole is equal to 6.022 times 10 to the 23rd of something. This could be molecules, it could be atoms, it could be anything. It all depends on what we're physically asking for. If I said I had 1 mole of iron, I would get atoms of iron. If I said 1 mole of iron to iron 3 oxide, then I'll get molecules of iron 3 oxide. It all depends. And then to go to grams, we're going to use molar mass. Molar mass is a way to look at an atomic density. Density, remember, is a way of measuring a mass in a volume. Well, molar mass is the way of measuring a mass in a quantity. Just like you could say, like, the average weight of an egg is 2 ounces. If I have 16 ounces worth of eggs, how many eggs would you have? Well, if 2 ounces per egg, you would have 8 eggs. So this is going to be a molar mass in the units of grams per 1 mole. Now, to figure out the molar mass, that is molecule dependent. Molecule dependent. So you'd have to look at the atomic mass of iron and the atomic mass of oxygen and multiply it by their subscripts. Iron is essentially 56. Oxygen is essentially 16. You put them together, you'd get what? Something like 160, if I'm not mistaken, grams within 1 mole. Now, a lot of chemistry is going from one scale to the other scale. On the early chapters, we focus on molecules, grams and moles, but on the later chapters, we'll actually go from grams to moles and back to moles of another thing. But so let's look at iron hydride, Fe2O3. If I want to know, I'm going to ask a series of questions. If I have, say, 111 grams of iron oxide, I can ask questions like, how many moles is that? How many molecules is that? How many atoms of oxygen would that be? All those questions can be answered using some simple conversions. This is where we get to the basics of converting in that. To convert, we're going to set up an equation with ratios so each unit cancels out the last unit. So first question, moles of iron oxide. I would set usually my first number over 111 grams of iron oxide. Our molar mass is 160 grams of iron oxide within 1 mole of iron oxide. If I plug those numbers in, so I'd say 111 times 1 divided by 160. That would give me the moles of iron oxide being 0.69, since we 3 sig figs, also 694 moles. Now the question, how many molecules? Well, we could keep expanding on this. 1 mole is equal to 6.022 times 10 to the 23rd molecules. Once again, moles and moles cancel out, and we've got molecules of Fe2O3. So I keep working 6.022 times 10 to the 23rd. That would be 4.17, well, rounds up to 1.8, times 10 to the 23rd molecules. And then to answer the final question is how many atoms, now we have to look at our balanced chemical equation. One molecule of Fe2O3 would contain 3 atoms of oxygen. 3 atoms of oxygen. We had to look at our chemical formula for that. So molecules of Fe2O3, molecules of Fe2O3. So I'll take my last number times by 3. The last answer, 1.25 times 10 to the 24th atoms of oxygen. We could go either way. We can go from molecules to grams, grams to molecules, or atoms, or what have you. It all depends on setting this up. I'll set up one more just like this, except we're going backwards this time. If I had 2.18 times 10 to the 25th atoms of N, how many grams of M would that weigh? So we start with our 2.18 times 10 to the 25th atoms. Start with that over 1. We use our Avogadro's number, 6.022, 10 to the 23rd atoms per 1 mole of N. Atoms N. And then 1 mole of N weighs 14 grams. So mole of N cancels mole of N. So 6.8, and then times 14, I would get an answer that something like 507 grams for the N. I'm rounding to the correct significant figures, but 507 grams. So that is our basics. We have to set up either atoms. This is one of the things we'll keep doing as we go forward.